Hi there. This video is going to be discussing lesson 4.1, derivatives of sine and cosine functions. So I'm just going to tell you now that for the function y equals sine x, the derivative is simply y prime is equal to cos x. And why is that? Well, if you think about what a sine graph looks like, okay, so a sine graph, and you can graph this on Desmos. So thinking back to what a sine graph looks like, so this is a sine function, right? Very rough sketch. So it goes up to 1, down to -1. Okay? And you were to find the derivative of that function, you are essentially finding, um, so for example, if I were to look at this sine graph and find out where the derivative is 0, which is right there, where the max and min are, right? That means those would be x-intercepts of my derivative. Okay, that's because that's where the derivative is 0. And if you look at this section of the sine graph, okay, so if you go from 0, 0 all the way to the max, you see that all those values, the derivative or the slope of the tangent, okay, will all be positive because it's all facing this way. It's increasing, right? Which means it'll all be positive, okay? So then you get this part. And then if you were to look at between the max and the min, if I were to ask you to find the slope of the tangent from the max to the min, you'll find the slope of all those tangents are negatives, which gives you these negative values. Okay? And continuing on that trend, you will find that the graph in red, and because I use red for the tangents, it looks a little confusing, so I'll change it to green. You will find that the green graph that I'm sketching right now is exactly the graph of cosine. Okay, because the cos graph starts at the highest at 1, goes down to -1, and comes back up to 2 pi. Okay, so thinking back to advanced functions, um, a cycle goes from 0 to 2 pi, or in other words, 0 to 360, because 2 pi radians is the same as 360 degrees. So, knowing that, you can use that same logic to say that if we were to look at a cos graph, then the derivative will be, well, you know what? Let's discover that one ourselves. Let's do that together. So if I asked you to find the derivative of cos x, what would the derivative be? Well, this is where sketching, so thinking back to when we sketched the acceleration, velocity, and position at time graphs, we had to use the graphs in order to find the derivative. So if I were to sketch y equals cos x, okay, which y equals cos x starts at the highest, goes down to the minimum at -1, and then comes back up 2 pi, so from 0 to 2 pi, okay, and then of course the minimum is going to occur in the middle, so at pi. If I were to sketch the derivative of that, let's start with the local max and mins. So here is a max, which means the derivative at that point will be 0. Here is a min, which means the derivative at that point will be 0. And here's a max, which means the derivative at that point will be 0. Okay, so I have that much. Now, I look at the cos graph, which again is the graph in green, and I want to draw tangents. So the slope of the tangents from here, from the max to the min, look at the blue lines I'm drawing. Would you say the slope of all those lines or the slope of all those tangents are negative? Yeah, and they are. Yes, they're negative, right? They're all negative slopes, which means for the derivative, starting at where it's 0, it's all going to be negative slopes. Okay? And then it should bounce back up because it should all be negative slopes. And then if you were to then look back at the cos graph and look at from the min to the max and to draw tangents at those points between the min and the max, all those blue lines I'm drawing, the slope of all those tangents would be positive, which means that section would be above the x-axis. Okay. Now, if I were to look at the graph I just sketched, that's this right here. This represents the derivative of cos x, which looks very familiar. Okay. It's not quite sine x, is it? Because sine x usually starts in the middle. Sine x usually starts in the middle, goes up, goes through pi, comes back down, ends at 2 pi. But instead, this is starting in the middle and going down first, which means that instead of sine x, the derivative of cos x is going to be negative sine x. Okay. Now, graphically, if you didn't understand the graphs, you can refer to the videos below, or if you Google proof that the derivative of sine x is cos x, I'm sure you'll find something on YouTube or Google as to why the derivative is cos x. Okay. But for now, for the sake of our lesson, what we need to know is the derivative of sine x is going to be always cos x, and the derivative of cos x will always be negative sine x. Okay? So here we go. Example 1. So y is 2 sine x, so which means y prime is going to be 2. Well, the derivative of sine x is just cos x. So 2 cos x. Done. Over here. Now I'm just going to erase this drawing just to give myself some space here. Okay, so what is the derivative of b? Well, y prime would equal to 2. Well, what's the derivative of cos x? It's just negative sine x minus 4, and derivative of sine x is just cos x. So then y prime is equal to negative 2 sine x minus 4 cos x. All I did was simplify this. This is supposed to be an arrow. It's a terrible arrow. You know what? I'm just going to erase that. There we go. Done. Over here. Here we've got a power rule, okay, and a chain rule. So the derivative of this would be 3 4 sine x squared. So power rule first, right? Okay. Then the chain rule. So now we got to find the derivative of the inside, which is just times 4. Derivative of sine x is just cos x, so 4 cos x. Done. Again, don't simplify these. I just want you to see that you're able to find the derivative as opposed to simplifying functions. Find the first, second, and third derivative of y fx equals sine x. So let's do it. So fx, so f prime, so the first derivative of sine x will just be cos x. Okay, that's the first derivative. Now let's check the second derivative then. Well, what's the derivative of cos x? It's just going to be negative sine x. Second is done. What about the third derivative? 1, 2, 3. So the third derivative will just be negative, and then sine x, derivative of sine x, we already said was cos x. So it's just negative cos x. And then fourth derivative, 1, 2, 4. So Roman numerals, I guess, you know what, I'm not going to use Roman numerals. Fourth derivative, just to keep it simple. 1, 2, 3, 4. The fourth derivative would be negative, and the derivative of cos x is negative sine x, which means two negatives give you a positive, so the fourth derivative just ends up being back to the original function itself. Now this makes sense because all these functions are periodic, right? So they're going to, if you find the derivative, it's going to end up being what you started off with because they are periodic, so the function repeats. Okay, so solve for the equation of the tangent line to the graph at the point x pi over 4. So our job is to find the equation of the tangent line to the graph. So what we need is y equals to mx plus b, right? Specifically at pi over 4. Okay. So to find the equation, we're first going to need the slope. Okay, the slope of the tangent. How do you find the slope of the tangent at any given point? You need the derivative. So f prime of x is going to equal to 3 cos x, because the derivative of sine x is cos x. So then f prime of pi over 4. Okay. So then that will equal to 3 cos of pi over 4. Okay? And then I was going to load Desmos up for you. Oops. Desmos. So pi over 4 is a special triangle. Okay, if you don't remember what the special triangles are, you could look it up, or save your time. Pi over 4. I'm going to make sure that the Desmos calculator is set on radians, which indeed it is. Okay, gives you 0.707, and that's not a very nice number, is it though? Well, the special triangle, thinking back to advanced functions, 1, 1, root 2, pi over 4, or in other words, the 45, 45, 90 degree triangle, which gives you 3. Cos is adjacent over hypotenuse, gives you 1 over root 2. Okay, so you have the slope now, which means I'm going to have y equals to 3 over root 2, which is just this simplified, okay, times x plus b. Well, how do we find b? Do we have a point to plug in for x and y? Well, we do have a point to plug in for x, but do we have one for y? We don't. We can figure it out though, because I can take the original function. So we've got fx is equal to 3 sine of pi over 4. Okay, to find the y value. So this should say pi over 4. So 3, well, what's sine pi over 4? Sine is opposite over hypotenuse, which gives you 1 over root 2 once again. Okay, so then that's my y value. So my y value is just 3 over root 2 is equal to, the slope is 3 over root 2. X value is pi over 4 plus b. Okay, so our job now is to find b. Well, all I need to do is rearrange this. Okay, so then rearranging it, I get, moving this to the other side, I'm going to get 3 over root 2 minus 3 over root 2 times pi over 4 equals to b. Okay, so then of course we need a common denominator, which means that if I multiply this side by 4 and this by 4, sorry, I ran out of space here, I'll get b is then equal to 4 times 3 is 12 minus 3 pi over 4 root 2. Okay, and then that being our b value, so therefore our equation is, the equation of the tangent is y equals to 3 over root 2 x plus 12 minus 3 pi over 4 root 2. Okay. Now, let's check this. Okay, so I've got, what was the original equation? Y equals to 3 sine x. So y equals to 3 sine x. And then the equation of my tangent is y equals to 3 over root 2, square root 2 x plus, plus 12, what was it, minus 3 pi, I think, over 4 times square root 2. Okay, so let's see if that is indeed the equation at pi over 4. Well, you can usually click it, right, and it'll tell you, but it might not tell you exactly what the value of pi over 4 is. So I'm going to type it in. So pi over 4, and so we want to know at the point pi over 4 and 3 over root 2, right? Okay. So there we go. So that green dot is pi over 4 and 3 over root 2. Again, where did pi over 4 come from? That's in the question. That's the x value. And the corresponding y value is just subbing that into the function itself. Okay. So then at that point, that blue line is the equation we just found. it does indeed look like it's the equation of the tangent at exactly that point on our function. Okay. Now, how would you know if you were wrong? Well, let's say instead of 3 pi, I put 8 pi, let's say. Looking at the blue line now, it clearly is not the equation of a tangent at the green line, which is what the question is asking for. Okay? There you go. Okay, that might be, let's see, next question. Okay, so now how do we differentiate some of these equations? Well, if we look at y equals tan x, how do you differentiate that? Well, what we need to keep in mind is tan x is sine x over cos x. Okay, and then we can differentiate that using our quotient rule. Okay, so using our quotient rule, the derivative of sine x, okay, which is just the top, will give me cos x times the bottom, which is just cos x, minus copy of the top, so sine x, and then the derivative of the bottom, or the denominator, is negative sine x, close brackets, over the denominator squared. Okay, now simplifying the top, I get cos squared x plus sine squared x, because two negatives give you a positive, over cos squared x. Now, looking at the numerator, cos squared x plus sine squared x, that is an identity that you should have memorized in grade 12 functions, because that would give you cos squared x plus sine squared x is equal to 1, which will give you 1 over cos squared x. Okay, and then from here, 1 over cos squared x is the same thing as saying secant squared x. Okay, if you were not sure how I did this last line, there are a couple identities that you should know or should remind yourself of from advanced functions. This is one of them. Another one would be the secondary trig ratios. So that's cotangent x is equal to 1 over tan, or the same as cos x over sine x. Okay. Another one you should have memorized is this right here, that tan x is equal to sine x over cos x. Another one, cosecant x is 1 over sine x. And lastly, secant x is 1 over cos x. Okay. Now a few more derivative examples. Okay, so first one, find the derivative using the chain rule. So the derivative of cos 3x, notice how the 3 is in the inside, which means I treat this as our variable. So then derivative of cos x is just negative sine x. So negative sine 3x. And then our chain rule, derivative of whatever's in there, times 3. Okay? That's done. Next, y equals to 2. Now, what's the derivative of sine again? Derivative of sine is just cos, so I copy that down. Cos of pi x times chain rule pi, because derivative of pi x is just pi. To simplify that, oh, I forgot the derivatives. To simplify that, I'll get 2 pi times cos pi x. Okay. Next example, y prime is equal to power rule. Bring the 3 down to give me 6 sine 2x. Okay, that's the power rule. Now chain rule. Now I got to find the derivative of sine x times cos x. Okay, that's the first term done. Now the second term, minus, bring that down, 4 times 2 is 8. 8 cos x times derivative of cos x is just negative sine x. Okay, so now I've got y prime is equal to, just simplifying this, okay, to give me 6 sine squared x cos x plus 8 cos x times sine x. And why is it a plus? Because 2 negatives. Okay, now what else do we have here? Find the derivative with respect to x for each function using the product rule. Okay, so product rule, derivative of x cubed is just 3x squared times cos x plus, now I copy down the x cubed, derivative of cos x is just sine x, or sorry, negative sine x. Done. So now the next line is just simplifying to give me 3x squared cos x minus x cubed sine x. Okay. And then the last example, we have y prime is equal to derivative of sine x is just cos x, so cos 4x times the chain rule times 4, okay, and then times cos squared x, which is this, because we're using the product rule, plus, now we're going to copy the first one, sine 4x times 2 cos x, where that 2 come from, power rule, and then the derivative of cos x is just negative sine x. There we go, and we're done. Just got to simplify this to give me, I'm going to bring this 4 in front, 4 cos 4x times cos squared x. I can't group these two together because this is cos 4x and this is cos x. They're not the same thing. Plus 2, oh sorry, not plus, minus because of the minus here. So minus 2 sine 4x cos x. And we're done. Take care.